Alright, so if you've ever seen 4th of July fireworks, oxidation is happening. So we're going to talk about redox again and figuring out the oxidation numbers. So there's some rules for assigning oxidation numbers, so let's look at that. So the oxidation number is either negative or positive. Sometimes we call it charges. You'll see when we talked about groups, remember we talked about their charge. So those are oxidation numbers. So if something's bonded, the charge that it would have if the electrons in the bond were assigned to the atom of the more electronegative element. I don't know if this makes any sense to you. Let's move on. So this rule is kind of confusing, so let's actually see it in action. So this is an important slide. If you have an element in its free or uncombined state, it's going to be oxidation of 0. So bromine gas, Br2, has a oxidation number of 0. Potassium, K all by itself. Phosphorus all by itself. Sulfur and carbon. It's just going to have a number of 0. So people forget this rule is a really important rule, so make note of that. So here's the rules. So if you have like a group, an element in a group number, remember if it's bromide, it's going to be a group 7, it's going to have a -1 charge. So the oxidation number is its charge. Most of the time hydrogen has a +1, that's a good rule to remember. Most of the time oxygen has a -2. So these are really helpful. This rule number 2, rule number 3 are really helpful to figure out other things. If you have an atom in an uncombined form, it's 0, like we just showed in the last slide. Neutral compounds, all of the sums of the oxidation numbers has to equal 0. And if you have a polyatomic ion, the sum must equal the ionic charge of the ion. So these might not make sense until we go through them, but these rules are important. So let's actually apply them so you get the idea. So oxygen always -2. And hydrogen's almost always +1. Oxygen almost always -2. So this is how we can use that information to figure out the oxidation numbers in water. So, and this is where it's really good to know your polyatomics. So in this case, potassium always is a +1. I have 2 of them. And I have this chromate here. And this has to be a charge overall of -2. If each oxygen is -2 and you have 4 of them, that's -8. So -8 here, it overall has to have a -2 charge. So if this is -8, that has to be +6. Let's try another one. Oxygen's almost always -2. I have 3 of them. This whole molecule has a charge of 0. So if I have -6 here, because of the 3 -2s, 3 times -2 is -6 on this side of the molecule, I have to have +6 on this whole side of the molecule to make 0 overall charge. So each one of these chromates is a +3. This is important, so make sure you understand how I went through that process. So let's try to do oxidation numbers for these. So SO2, the whole molecule is 0. Oxygen's always -2. You have 2 of them, so that's -4 on this side of the molecule. So this sulfur has to be +4. All right, let's try B. The overall polyatomic has a -2 charge. You have a -6 here, so that the carbon has to be +4. So there you go. Let's try this. Each sodium is +1. You have 2 of them, so that's +2 on this side. Sulfate is -2 overall. You have -8 on this side, so sulfur has to be +6. Ammonium, +1 here. Each hydrogen is +1. You have 4 of them, so that's +4. So how would you get a +4 and overall getting a +1? So nitrogen has to be -3. So make sure you can look through this and do these. These are really important. Try those yourself. See if you can get that. And then let's talk about redox and the change in oxidation number. So if you increase your oxidation number, you are oxidizing. If you decrease your oxidation number, you're reducing. So if you become more negative, you are reducing. So let's look here. I have silver plus 1 and now it's 0. So it's becoming a lower number. It's reducing, so it's becoming reduced. And then somebody has to be oxidized. So copper becomes more positive, so it's oxidizing. And here's showing how this would happen in how you could get another redox reaction going on. So here's a problem. Let's see if we can figure out who's oxidizing, who's reducing. So remember, anybody by himself is going to be 0, 0. And then we have to look at the periodic table. Bromine's in group 7, so it's a -1, and hydrogen likes to be a +1. Here, chlorine's combined with somebody, so he's group 7, he likes to be -1 in a combination, and H is always +1. So chlorine went from 0 to -1, bromine went from -1 to 0, so chlorine became more negative, so he's reduced. And the other guy's oxidized. So try with these ones yourself, and let's see how you do on your quiz, which is not correct. You'll have to pause me and try all these possibilities and see which one, and now I'll give you the answer. So that is +2 plus 2 minus 2. What's the oxidation number of cobalt in this? So pause me, go through the process, and try it. So the answer would be that for cobalt. Now, which element has the greatest change? So you're going to have to pause me and figure out who becomes a bigger change in oxidation number. So lead in this case. So that's the end of redox. So I hope you got a lot. Figuring out oxidation numbers is a super important skill, so try that as best you can, and we'll talk soon.